Hi, and welcome to this 10-minute lesson on projectile motion. So what I'm going to do is run through my top tips and things that honestly teachers assume you know about projectile motion. And then we're going to do the two types of projectile motion question you could be given. So projectile motion, if I share my screen, projectile motion makes some assumptions. So it says that the horizontal acceleration of an object is 0 unless we're told otherwise, which means horizontally, when we have a projectile, we can assume that the speed is constant. So we can just use speed as distance over time. We don't need to use anything more complicated than that. The vertical acceleration is gravity, g, unless stated to be different. And sometimes a question might ask you to use g as 10, and if not, we can use g as 9.8 or 9.81. Now, the reason I've talked about horizontal and vertical is because that is how we do any projectile motion question. We split it into the horizontal motion, going lengthways, and the vertical motion. The reason we can do that is we have usually different information about the different types of motion, and we can often use the vertical acceleration to find us the time, and time is the only quantity that's the same for both horizontal and vertical motion. And finally, at the maximum height, so in our projectile at the maximum height, its vertical velocity is 0. Now, there are two types of projectile motion question. The first type is when something is launched and it falls. So think throwing a rock out of a window, a cannon off the edge of a castle, all those kind of questions and all the ridiculous scenarios that we get in the exam. But that projectile it just falls. It only has one part to its motion. It just falls. So we still split it into horizontal and verticals, but it's just falling. The second type of question is when we have two parts of the motion. So something is launched from ground level or from some height just above ground level, and it goes up and then it goes back down. And again, we resolve into horizontal and vertical components, but it goes up before it goes back down. And so we can consider the upwards part of the motion separately to the downwards part of the motion, or the overall trajectory of the projectile. So let's have a go as a worked example of each of these types of questions. A water balloon is thrown horizontally off a ledge of height 25 meters and lands a horizontal distance of 50 meters from the launch point. Find the initial velocity of the water balloon. Now, there's a key word in this question that most people have trouble with: horizontally. If something is thrown horizontally, then it means that vertically, the initial velocity, oh gosh, that wasn't very neat, the initial velocity, u, is equal to 0. And if something is thrown from a height horizontally, the only way that projectile is going to go is down. So if I'm on the ledge here and the water balloon is being thrown off horizontally, the only way it's going to go is it's going to go down. It hasn't got an upwards part of its motion. So what we're going to do is we're going to use the vertical aspect of the motion to work out the time it takes for that water balloon to hit the ground, and then we're going to use the horizontal distance and that time to work out the horizontal speed. And because there's no acceleration, the initial horizontal speed is the same as the final horizontal speed or velocity. So vertically, we know that u is 0. We know that it falls 25 meters. We know that the acceleration is gravity, so I'm going to use 9.81. and we're interested in finding t. We don't care about the final vertical velocity of the water balloon, so we're not going to use that. So we're going to end up using the equation S is equal to ut plus a half at squared. Substituting in, that gives us 25 is equal to 0 times t plus a half times 9.81 times t squared. I should have written a bit smaller. That disappears because 0 times anything is 0, which means that t is equal to the square root of 25 divided by a half times 9.81. And so popping that into a calculator, which I thought I'd done, but I haven't, 25 over 0.5 times 9.81, that gives us 2.26 seconds. And I've rounded that to 3 significant figures. So we now have that the time is 2.26 seconds. And horizontally, the distance is 50 meters. So we can use speed as distance over time. So V is S over T, which would be 50 over our 2.26, which gives us a horizontal speed of 22.1 meters per second. And that's how we do those questions. We always use the vertical motion to find the time that we need, and then we use that time to work out the horizontal component. So moving on to the slightly trickier situation where we have two parts to the motion. We have something launched at an angle, so it goes up and then it goes back down. So in this scenario, a hockey ball is launched from a point A with speed 30 meters per second and an angle of elevation of 30 degrees. The ball hits a tree on its downward flight at point B, 8 meters above A. Find the time taken to reach the greatest height, the time taken to travel from A to B, and the speed with which the ball hits the tree. So, to do this, what we are going to do is to find the time taken to reach the greatest height. We are going to consider the vertical motion of the hockey ball. Now, I always like to make a little sketch when doing these questions. So at point A, make this point A, the ball is launched with 30 meters per second at an angle of 30 degrees. And I instantly am going to resolve that 30 meters per second into horizontal and vertical components. And I can do that using trigonometry. So the horizontal component will be 30 cos 30, and the vertical component will be 30 sine 30. The ball is then going to get to a maximum point, fall back down and hit point B where we have a tree. I'm not even going to draw the tree because that's going to be too embarrassingly bad, which is 8 meters above the ground. So I'm going to find the time taken to hit the greatest height. So I know that again, we're doing vertically. So I'll just jot that in so we don't forget. So vertically, the initial velocity is our 30 sine 30, which actually works out to be 15 meters per second. Our v, at our maximum height, we know that the velocity vertically is 0. We know that the acceleration is minus 9.81. Now, why is the acceleration minus in this scenario when I didn't make it a minus in the other one? Well, this is because I'm taking positive to be up. We're considering the upward portion of the journey, and so I have taken the initial velocity upwards to be positive, and the acceleration, gravity is acting in the opposite direction. So I have assumed that the acceleration is negative, which makes sense because it's slowing down to hit 0. So that actually makes sense with what we need. And I'm going to use, if I'm looking for the time, then I'm going to use v is equal to u plus at, which would be 0 is equal to 15 minus 9.81 t, which gives me a t of 1.53 seconds. So that's the time it takes to reach the greatest height. So let me clear all that. So that's 1.53 seconds. I now want to know the time taken by the ball to travel from A to B. Well, I've already got the time it's taken to reach the greatest height. So what I really need to work out for this question is the time it takes to get from the greatest height to B, to 8 meters above A. So to do that, what I can do is work out the greatest height. So using the previous values that we had of u is 15, a is minus 9.81, and v is 0. Now I'm not going to use the time here. The reason I'm not going to use the time is it's a value we worked out. So if I get it wrong, I'm going to carry that error through. So it's much safer to try and use something that hasn't been worked out by ourselves. And we can do that. We can work out S using U, A, and V. We can say that V squared equals U squared plus 2AS, which would give us 0 is equal to 15 squared minus 2 times 9.81 times S, which would work out as S is equal to 15 squared divided by 2 times 9.81, and the minuses all helpfully cancel. And that gives us 11.47 meters. The reason I've worked out the greatest height is I now know that I'm going to be working out the time it takes from the ball to get from 11.47 meters to 8 meters, or the time it takes to travel 3.47 meters, the difference. So we're going to now take our starting point as the top of the flight. So if I start at A, I've got my greatest point up here, and then I'm traveling down to B. If we take this now, we're taking from our greatest height, which I'm going to label C, and we're traveling to B. And so what I can do is I can split my motion into the two halves, which is exactly what I've been doing all along. Is I'm now going to look at just the downward portion from the greatest height to the point B. And for that, our initial velocity is 0 because we're starting at the maximum height. We don't know the velocity at B, but we do know that the acceleration is now happening in the direction of our motion, so we can make that positive. That's 9.81 meters per second squared. we can use that our distance we're going to travel is 3.47 meters vertically. And so our time can be worked out by using S is equal to UT plus a half AT squared. And helpfully, because our U here is 0, that bit's going to disappear. So we're going to get 3.47 is equal to a half times 9.81 times T squared. And if we have a go at rearranging that, we work out that T is T works out at 0.841 seconds. I'll just round it to 0.84 seconds. Which means the time taken to travel from A to B will be 1.53 plus 0.84, which works out at 2.37 seconds. So we had 1.53 seconds here and 2.37 seconds here. Now we move on to part C, the speed with which the ball hits the tree. So we can use what we've just worked out at the point where we hit the tree to work out the velocity vertically of the ball when it hits the tree. So using, again, our U equals 0 meters per second, our distance is 3.47 meters. Now, the reason I'm using that, even though we calculated it, is because there's no other way to do it. I'm either going to have to use the distance we calculated or the time we calculated. And our acceleration is 9.81. And I'm going to use V squared equals U squared plus 2AS. Helpfully, U squared is 0, so V squared is equal to 2 times 9.81 times 3.47, which means V vertically works out at 8.25 meters per second. Now, don't worry if you end up getting something slightly similar like 8.24 or 8.26. It can be rounding errors. And in an exam, they give you a bracket that you can fall within, and they do allow for rounding errors. So don't panic if you get a slightly different answer. Now, that's our vertical velocity. They want to know the velocity with which the ball actually hits the tree. And so what we can do is we can use a triangle to work that out. Now we know that the horizontal, we haven't used any horizontal motion yet. That's because it's going to come in here. The horizontal velocity hasn't changed. So that still remains as our 30 cos 30 from the beginning. So we've got 30 cos 30 horizontally, and we've got 8.25 vertically, and we want to know the actual velocity, which I will label as a big V. I'll put that as a little v, V vertical, which means that we can use Pythagoras, because this is a right-angled triangle, to say that big V squared is equal to 30 cos 30 squared plus 8.25 squared. And we end up with V is equal to the square root of that, which works out at 27.3 meters per second. And that would be the speed with which the ball hits the tree. And that's it. If we can resolve our projectile motion into horizontal and vertical components. We can remember those assumptions that we make, then we can answer any projectile question we are given. It is no more difficult than that. We either have just downward motion or motion in two parts, upward and then downward. And at that point, we can split it into going up and then going down and use that information to work out the overall time or the overall trajectory of our projectile. I hope that helps. Thank you for watching. If you have any questions, drop us a message, but otherwise I will see you again next time. Thank you.